Monday, April 8th, 3 p.m. Mountain Time, 2019. Guys, what we're looking at here is a full disk image of the sun through the Solar Dynamics Observatory. That's a spacecraft that was launched 10 years ago, back in 2009, to monitor the sun. What we're looking at here is a sunspot on the eastern limb of the sun. That's the left-hand side. The right-hand side is the western limb of the sun. This is a very large sunspot. In fact, it's a planet-sized sunspot. Many Earths could fit right inside that sunspot there. It's moving towards the Earth as it's moving from left to right as the sun rotates from left to right. If you go to the website, you click on the Sun tab here at MrMBB333.com. That tab will take you to the SDO, the Solar Dynamics Observatory website, where you can look at the sun through many different filters, different wavelengths. The sun, much like planet Earth, has many different layers of atmosphere. All of these different filters monitor different layers of the sun's atmosphere. The one that I just showed you first was the surface of the sun. We go up here to the top and we can monitor multiple layers of atmosphere the sun has. Right now there's a storm in the atmosphere of the sun. It hasn't left the sun yet. Right now it's still stationary. But if the magnetic polarity on the surface of the sun in that sunspot starts to intermix, it will create a solar flare, which will create a coronal mass ejection. And what we're going to do here in this slideshow is take a close-up look at this active region above the sunspot. That active region is a combination of negative and positive energy. When that energy intermixes, it creates a solar flare, and that solar flare emits coronal mass out into space. And if Earth is in the line of that coronal mass, it creates a geomagnetic storm on planet Earth. And depending on many variables, how big the sunspot is, how fast the sunspot emitted the coronal mass ejection off the surface of the sun, the magnetic polarity, there's so many factors involved determining how strong the geomagnetic storm would be on the Earth. It's impossible to say at this point. But I will say at this point, magnetic polarity on the surface of the sun is very close to touching. And when it touches, that's what creates the eruption. And you can see right here the negative and positive charges. The red and blue are negative and positive. Look how close together they are. In most cases, you'll see blue over here and red over here, and they're very far apart, which means there's little, if any, chance for a solar flare or a coronal mass ejection. When they're that close, that generally means there's going to be an eruption of some sort. That is extremely close. If there were to be one right now where that's positioned, it definitely would not be Earth directed. Earth may feel some of the energy from the coronal mass ejection, which could cause a geomagnetic storm, probably small, but the more it moves to the right, left to right, the greater the chances are. And another thing too, this sunspot can change. It's very complex. It can shrink away and go to nothing by the time it gets over here where it's Earth directed. Then again, it could get larger. I've seen it do both. I've seen it stay the same. I've watched these things for years, and they're very complex and very hard to predict. Right now, it's not Earth directed, but it will be in the next couple of days. Back in 2012, July of 2012 to be exact, July 23rd, there was a very large CME instigated by a solar flare off the surface of the sun, and this is it right here. I recorded this from the SOHO LASCO C2 instrument, July 23rd of 2012. If this would have been Earth directed, it would have created at least what was known as the Carrington event of 1859. This one probably would have been a little bit stronger, but luckily, right there it just went. And if you blinked, you would have missed it. I'll play it again because it went off so fast I put it in slow motion, right there. That was an incredible solar flare slash CME. Look at that. And not only it was huge. One thing I will say about Earth, though, Earth is small. That thing could be as big as the universe, and Earth is only so big. Only so much of that energy is going to influence planet Earth. The rest of it's going to go right on by. But the thing of it was about this one was its incredible speed. It was moving off of the surface of the sun at over 6 million miles per hour. That's faster than the movement of the event that caused the Carrington event back in 1859. And the Carrington event spawned from an area right up in here. That's where the solar flare came from. There was a collection of sunspots in this area right here. There was probably a collection of 5. There was one main one, and then there were 3 or 4 smaller ones. And that's where the Carrington event came from. This sunspot right here, I'm not saying it's going to be a Carrington event by any stretch of the imagination. I'm just saying it's a very large sunspot, one that we haven't seen for a while. Here is the article about the sun eruption that I just showed you from July of 2012. It was known as the Solar Superstorm event of 2012, and that's the one that I just showed you. And what made it so unique was its incredible speed. At 6.5 million miles per hour, that would have wreaked havoc on Earth's satellites, the electrical grid, and in today's world, we rely so much on electricity for basically everything that we do. I'm using electricity right now in multiple senses, with regard to my phone, this microphone. I've got a little fan over here that keeps my laptop cool, my laptop itself, the lights. We all use electricity. The last time this happened, the Earth wasn't so dependent on electricity. One thing it did disrupt, though, was the telegraph. In fact, one of the telegraphs up in Canada, I think, it caused it to malfunction where the main components of the telegraph fried. But that was over 150 years ago. It could happen again, but a lot of things have to occur in order for something like that to happen. And in fact, here's an article dated today, April 8, 2019. Scientists are predicting the sun's activity will remain weak during the next solar cycle, and the next solar cycle is solar maximum, and they're looking for it to be a weak solar maximum. And those of you that follow this, solar minimums and solar maximums occur on 11-year cycles. The last solar maximum was actually weaker than the solar maximum before it. So it looks like they're going to be consecutively weaker and weaker as we move forward. So this sunspot here should not be a problem for planet Earth, even though, yeah, it's a very large sunspot with a very large active region up in the atmosphere. Remember, the sun has atmosphere like the Earth. This energy is up in the atmosphere of the sun. It's still there right now as I do this video. The only thing that will move that energy up in the atmosphere is if this sunspot becomes too active on the surface, and it will cause that energy to erupt off of the surface of the sun. And then whatever is in its path, whether it be the Earth, whether it be Mars, Venus, Mercury, they'll take the brunt of that coronal mass that comes off the surface of the sun. So right now, Earth is not in the path of any solar storms, but that doesn't mean that it couldn't be in the days ahead. But right now, they're saying that the next solar cycle, which will be solar maximum, is supposed to be weaker. I want to talk briefly about the Parker Solar Probe. This was launched 239 days ago, and I gotta be honest, I was really looking forward to this thing as they sent it towards the surface of the sun, up in the sun's corona. And as you can see right there, that little video clip that showed it monitoring the sun from, I think it's supposed to get within 4 million miles or something like that of the sun. Well, it's been up now for 239 days, and we've yet to see a photograph of the sun. So we're anxiously awaiting. I don't know if there's some sort of a technical glitch, but we should be seeing photos of the sun anytime. If you go to the multimedia link up here and click on images, there are no images yet from this spacecraft. There's all kinds of artist renditions, which we've all seen those, but for whatever reason, we haven't seen any yet. So we will still patiently wait. Here is a story from spaceweather.com going back to July 23rd of 2012, and it talks about this very solar flare CME, this one right here that I just showed you, that went off of the surface of the sun at 6.5 million miles per hour. In fact, here's the article. A coronal mass ejection CME blasted away from the sun this morning with rare speed, 2,930 kilometers per second, or 6.5 million miles per hour. And if that would have came in contact with the Earth, you can see it went back that direction, just behind the western limb of the sun. That's consistent with what I just showed you. It went that direction there. But if that would have came towards the Earth, it would have created issues not only with the electrical grid, spacecraft, more than likely airplanes that would have been en route at that time from point A to point B. It could have caused malfunctions with their electrical panels. That was a very strong, high speed, one of the fastest ever recorded that would have made it from the sun to the Earth in less than 15 hours. Absolutely mind-boggling if you stop and think about it. Don't forget to check out the website, guys. I've got new photos in the Sky Phenomena photo gallery, MrMBB333.com. New news reports up in the daily report that are updated daily, sometimes multiple times a day. All the data you see right here is real-time data, updated 24 hours a day, 7 days a week. Thanks for watching. Have a super day, and be safe out there, guys.